Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. In today's episode 4.2, ICRC-1 tokens, we're going to be taking a look at how you can deploy a local ICRC-1 ledger, initialize it with your own custom token data, and then how you can use that token in a local project, or how you can also look into deploying that ICRC-1 ledger on the mainnet and thus deploying your own ICRC-1 custom token on ICP. So before we get started on the hands-on portion of this tutorial, let's first take a look at some of the concepts and terminology that we'll be using. So first of all is that acronym ICRC and the number 1 after ICRC-1. You also may have seen ICRC-2, ICRC-3, ICRC-7. And so what does ICRC mean? So the acronym ICRC stands for the Internet Computer Request for Comments, and it's a standard that was created by the Internet Computer Token and Wallet Standard Group. This is a working group that creates standards not just for tokens, but other ICRC standards for the ICP network. Standards defined within the ICRC group are not specific to tokens. Anything can become a standard or have a ICRC standard associated with it. Some examples that may be standardized are metadata fields or digital assets such as tokens, or digital assets that are different from your traditional token. The purpose of the ICRC-1 standard specifically is it is a base standard used for creating a universally accepted standard for creating and recording token transactions on ICP. It defines the general functionalities of ledgers, and any tokens and their corresponding ledgers that want to support ICRC-1 must fulfill all of the requirements within the standard. And there are several extensions of the ICRC-1 standard, such as the ICRC-2 standard. Not all ICRC standards must be extensions of the ICRC-1 standard though, but we will be taking a look at the ICRC-1 standard in this tutorial, and then looking at the ICRC-2 extension and how that extension expands upon the basic functionalities defined in the ICRC-1 standard. So in the last tutorial, 4.1, we took a look at the ICP ledger, and in this tutorial, we're going to be taking a look at the ICRC-1 ledger. So what is the difference between these two ledgers, and why are there two different ledgers? Or two different types of ledgers rather. So the ICP ledger is a specific implementation of a ledger. It did not initially follow any sort of standard because it existed prior to the creation of the ICRC-1 standard. Whereas the ICRC-1 is the official standard, and it is not a specific implementation of a ledger. There are several different ICRC-1 ledgers with different implementations, but they all follow that same defined standard. Each of the ICP and ICRC-1 ledgers use different endpoints, have different transactions, different block objects, and they have a number of other more subtle differences, but those are the primary differentiating factors. The other important factor to note is that they use a different type of account. So the ICRC-1 standard specifies accounts as a struct data type that contains a principal and an optional subaccount, whereas the ICP ledger uses the account identifier to represent accounts, and these are essentially a hash of an ICRC-1 account. So an ICRC-1 account can be converted into an account identifier, but an account identifier cannot be converted into an account. This factor provides the ICP ledger with a level of anonymity, though it means the ICP ledger cannot have the same internal representation as an ICRC-1 ledger. So that may be a little bit confusing. So just to summarize, the ICP ledger uses an account identifier that is a hashed value, and that hashed value starts off as the principal and sub-account that make up an ICRC-1 account, and then it gets hashed and becomes the ICP account identifier. The ICRC-1 account just has those values as the principal and the sub-account, and it does not hash those values into a hashed format. One more important note is that the ICP ledger implements all of the ICRC-1 endpoints, but it is not an implementation of an ICRC-1 ledger due to its use of that account identifier and not the account value. Another important term, and one that we mentioned briefly in the last tutorial 4.1, is index canisters. This is a type of canister that is used to query all of the transactions within a ledger and then parse through those transaction records to just return the results that you're looking for. On the ledger, you can do this workflow, but you're going to have to query the entire ledger's transaction history, and that may be very long and have a high amount of latency in order to return the information that you're looking for. So as an alternative, the index canister can be queried, which provides an endpoint for querying the transaction list for a specific account or other specific account information, such as its current balance. And each ledger has an associated index canister that performs this function. So on the mainnet, there is a single ICP index canister for the single ICP ledger. And then since there are several ICRC-1 compatible ledgers, there are several ICRC-1 index canisters for each of those individual ledgers. So like I mentioned, the ICRC-1 standard is a base standard, and it intentionally excludes certain ledger functions that may be necessary for building diverse decentralized finance applications. Some of these functions that it does not include are transaction notifications for smart contracts, an interface that is used for fetching blocks, or pre-signed transactions. The ICRC-1 standard has an endpoint called the ICRC-1 supported standards endpoint, and this is used to return the supported extensions of the standard. It currently returns all specifications implemented by that individual ledger. So one ledger may only support the base standard of ICRC-1, or it may support extensions such as ICRC-2. So lastly, before we jump into the hands-on portion of this tutorial, we're going to talk about metadata and the role that it plays for an ICRC-1 token. The ICRC-1 standard allows for several metadata fields to be specified. These are used to help improve the user experience and simplify the token's integration with wallets. Each of these metadata fields is an arbitrary Unicode string that uses the format namespace:\key, where the namespace ICRC-1 is reserved for metadata defined for the ICRC-1 standard. So the supported metadata fields are ICRC-1 symbol, which is the token's currency code, ICRC-1 name, which is the token's name, ICRC-1 decimals, which is the number of decimals used by the token, and ICRC-1 fee, which is the token's default transfer fee. So now let's take a look at how we can deploy a local instance of an ICRC-1 ledger. We're going to start out by making sure that we have set up our developer environment according to the instructions in 0.3 developer environment setup. And then we are going to create a new project. So to create a new project, I'm going to first run dfx start clean background. And we can see that I already have dfx running. And then I'm going to use dfx new ICRC-1 ledger canister. I'm going to select Motoko. I'm going to select no front end canister, and then I'm not going to be adding any extra features. And then I'm going to navigate into that new directory with the cd command. And so next I'm going to need to get the most recent WASM and Candid files for the ICRC-1 ledger implementation. So to do that, I'm going to open up the ICP dashboard, and I'm going to scroll down to releases. I'm going to take a look at this most recent release, and I'm going to copy this commit value. And first I'm going to need this dfx.json file. I'm going to copy this. I'm going to open up a new VS Code window, and I'm going to open, and then I need my developer journey folder, and then my ICRC-1 ledger canister project. We'll open that up, and then I'm going to open I'm going to open the dfx.json file. I'm going to remove all the content that's in it, and then I'm going to go back over here, make sure I have this copied, and paste that in here. And I'm also just going to toggle the word warp so we can take a look at the entire URL on the window without having to scroll. And then I'm going to go back over here. I'm going to take this release value. I'm just going to replace the current release value that's in these URLs here. So we'll just paste that, and I'm going to Control S to make, or Command S to make sure that I have this saved. And so then we're going to go back over to our tutorial. We're going to use that same Minter identity that we created in the last tutorial. And if we need to export that Minter identities principal as an environment variable again, we can use dfx identity use Minter, and then we can use export Minter account ID equals dfx identity get principal. And so now for this tutorial, we are going to be defining a series of variables that are going to be used for configuring our own custom token on our own custom ICRC ledger. So this is going to be a little bit different from how we passed these arguments into the ICP ledger when we created it in the last tutorial. Since we're going to be having lots of different metadata fields and we may be reusing them for different functions later on, we're going to just export all of them as environment variables. So for this, we're going to export token name equals, and for this, we're going to call it dev journey token. Then we're going to also export the token symbol. And for that, we're just going to call it DJTK for dev journey token. And then we also want to set the identity that we're going to use to deploy the ledger. So in the last tutorial, we used our dev journey identity, so we're going to use that as well. So dfx identity use dev journey, and then export, we're going to call it deploy ID equals $ for parenthesis dfx identity get hyphen principal. So when we go to deploy our ledger, it's recommended to mint some tokens so that we can interact with the ledger and do some basic functionality like sending tokens to other identities. So to do that, we're going to set an amount of pre-minted tokens, and then we're also going to set a transfer fee. So we're going to export pre-minted tokens equals, and for this, we're going to have it be 10 billion. And then export transfer fee equal, and this is going to be 10,000. So next we're going to set some values for the ledger's archiving options. These values that we're going to set in this tutorial are recommended, but you can alter them to fit your individual project's needs. So first we're going to create a new identity called dfx identity new archive controller. And then we're going to use that identity, so dfx identity use archive controller. Then we're going to export archive controller equals dfx identity get principal. And then we are going to export trigger threshold. That's going to be 2000. So the trigger threshold is the amount of blocks that, once that threshold of blocks is hit, there is going to be a number of blocks set to be archived. So then we're going to export num of block to archive, and this is going to be the number of blocks that once that trigger threshold is hit, this number of blocks is going to be archived. So in this case, once 2,000 blocks are hit, the most recent 1,000 blocks are going to be archived. And then lastly, we're going to export cycle for archive creation, and this is going to be the amount of cycles to be sent to the archive canister when it's deployed. And this is a large number that I'm just going to copy and paste to make sure I don't miss a 0. And then lastly, before we deploy, we are going to specify which standards we want our ledger to support. And we're going to use the features flag to set this. And so if we want to only support the ICRC-1 standard, we're going to set this to false. But if we also want to support the ICRC-2 extension, then we're going to set it to true. And so since we're going to take a look at the ICRC-2 extension later in this tutorial, we're going to set this to true. So feature_flags equals true. And now that we have all of these environment variables set, we're going to use them to act as init args for our canisters deployment. So as you can see, we have this big long command here that specifies all of these different fields. And so I'm just going to copy this code to make sure that I don't have any typos in this. I'm going to paste that, and we're going to deploy our ICRC-1 ledger. And now we can see that it deploys correctly. Okay, so now our ICRC-1 ledger canister is deployed to our local environment. Now, if you wanted to deploy this to the mainnet, there are a couple of steps that you will need to do. You'll have to remove the argument specified ID, and that's because your canister is going to receive a unique canister ID once it's deployed on the mainnet. You'll also need to make sure that you use the network IC flag to specify deploying it to the mainnet network instead of the local network. When you are looking to deploy your token to actually be used by others on the mainnet, you'll want to specify the amount of initially minted tokens by setting an initial values equal vec initial values number. And it is always recommended to set the archive option field, otherwise the ledger's capacity is going to be limited to the memory of a single canister. And like all other projects on the mainnet, it's always recommended that you make sure that your canisters have sufficient cycles and make sure that you top them up as needed so they don't have any issues when they run out of cycles. And this is especially important for ledger canisters since they will require cycles to create new instances of the archive canister on demand. So like the ICP ledger, you can interact with the ICRC-1 ledger using a DFX canister command. You can also use the IC CDK for making intercanister calls to the ICRC-1 ledger or the ledger ICRC-JS library. In this tutorial, we're just going to take a look at using the DFX canister command and the candid UI. And we'll have some links to the IC CDK and the ledger ICRC-JS options as well. So first, let's take a look at the ICRC-1 endpoints. Remember that we will cover the endpoints for ICRC-2, and in order to follow along with that, you will have to have set that feature flags to equal 2 when we deployed our canister in the last step. We can go ahead and confirm that the local canister supports ICRC-2 by using DFX canister call, ICRC-1 ledger, canister, and then ICRC-1 supported standards. And then we're going to have some empty parentheses at the end here. And here we can see that we support ICRC-1, ICRC-2, and also ICRC-3. Next, if we want to get the token symbol for the ledger, we can use DFX canister call, ICRC-1 ledger canister, ICRC-1 symbol, and then with empty parentheses again. And here we can see it's giving us our dev journey token symbol. We can also query the token's decimals, so we can use that same DFX canister call, ICRC-1 ledger canister, and then instead ICRC-1 underscore decimals. And here we can see that it's going to be 8 of data type nat8. If we want to get the token's full metadata, we can use ICRC-1 metadata with empty parentheses, and here we can see the token decimals, the token name, symbol, fee, and the max memo length for the token. And the memo length is for sending memos with transfers. We can also take a look at the total token supply. So we can do ICRC-1, or we can do DFX canister call ICRC-1 ledger canister, and then call the endpoint ICRC-1 underscore total underscore supply. And we can see that it is 10 billion. We can also check the fee by calling the ICRC-1 fee endpoint, and we can see that that is 10,000. We can return the minting account principal with ICRC-1 minting account. And we can see that principal, and we can see it doesn't have a sub account. We can fetch the balance of an account, and this is going to use a slightly different command format since we are going to not just pass empty parentheses. So we're going to do ICRC-1 underscore balance underscore of, and then we're going to use record owner equal principal, and then the deploy ID variable. And I'm just going to copy this value to make sure that I don't have any typos. And we can see that since this principal was the principal that deployed the ledger, it has the full balance of the 10 billion tokens. And then to transfer tokens, we can use the command ICRC-1 transfer, and then have a record passed into this command where the to record is a principal value of who we are transferring those tokens to, and then the amount. And so I'm just going to go ahead and copy this full command since this one is a little bit on the longer side to type out. And we can see that the result is variant OK equals 1. And so that means that the transfer was successful. Now, if we take a look at the ICRC-2 endpoints, so I mentioned that ICRC-2 is an extension of ICRC-1. It enables the approve transfer from pattern that is popular in the Ethereum ecosystem through the ERC-20 token standard. This specifies a way for an account owner to delegate token transfers to a third party. In ICP's case, this is usually a canister. And so, for example, if we want to approve 100,000 tokens for this principal, we can use the DFX canister call ICRC-1 ledger canister, and then we're going to use the ICRC-2 underscore approve endpoint. And here we're going to approve the amount of 100,000 tokens to the spender account with this principal. And so I'm just going to copy the latter half of this command and paste that in and hit enter. And we can see that I have an error. The replica returned, let's see, the minting account cannot delegate mints, error code none. So let's see, DFX identity use dev journey. And let's try that again. And we can see that it was okay that time. So I just had the wrong identity set. And then we can confirm that this account or that this command worked correctly by checking that principal's allowance by doing the DFX canister call ICRC-1 ledger canister ICRC-2 underscore allowance. And then this is also going to be fairly long, so I'm going to copy this. But what this one does is it's making sure that the account of deploy ID, and the spender has set the correct allowance for that spender. And we can see allowance equals 10,000, and it doesn't have an expiration. Alternatively, you can set an expiration date, so meaning the sender only has until a certain point in time to spend those tokens. And to do that, we can edit the command to now use the ICRC-2 transfer from endpoint. So DFX canister call, ICRC-1 ledger canister, ICRC-2 transfer from. And then here we are going to have the amount be 90,000 from the deploy ID to record owner deploy ID. And so we'll go ahead and send or paste. We'll go ahead and copy that and paste that. And we can see that that was successful since the command is returning the block index of the transaction. And like all other backend canisters, you can interact with this ledger in the same way through the Candid UI. You can use all of the same methods that we just used manual terminal commands with through the UI. Since it would be redundant to just go through all of those again, I won't display the Candid UI, but as we've looked at in the past, the Candid UI URL is going to be outputted when you first deployed your canister. So if you scroll back up, it's going to be this highlighted green text for the Candid UI. So that will wrap up today's episode of the Internet Computer Developer Journey. If you enjoyed today's episode, be sure to like and subscribe to the DFINITY YouTube channel. If you have questions or comments, be sure to leave them below or check out the ICP Developer Forum or the ICP Developer Discord server. Either of those are great resources for asking questions or communicating with other developers also on their developer journey. Until next time, take care.